In this tutorial, we are going to do a brief overview of the periodic table. And first of all, we can see that the periodic table is organized in vertical groups or families and horizontal rows called periods. The vertical groups are numbered from group 1A and 2A here on the left, groups 3A through 8A over here on the right. These groups, the group 1A and 2A, here let me get a pen going here, groups 1A and 2A, as well as groups 3A through 8A, these are all called the representative elements. And the reason they're called that is because they include elements with a wide variety of properties, solids, liquids, and gases. So they represent what a lot of elements in the earth are like. The periods of the periodic table run across horizontally, and the properties in a period will increase or decrease as we move from left to right across the periodic table. And if we could graph these properties, we would find patterns. And for instance, we might find an increasing property as we move from left to right, and then as we drop down to the next period, it will decrease and then increase again as we move from left to right. Being pretty vague here on purpose because we are going to introduce what these properties are in the next tutorial. But if we could graph them, we would see a really regular trend, hence the word periodic in periodic table. In the groups, elements within a group have similar properties. And why is that? That is because those elements contain the same number of electrons in their outermost energy level. So in group 1A, the elements have 1 electron in their outermost energy level. In groups 2A, they have 2 electrons in their outermost energy level. In group 3A, 3 electrons in the outermost energy level, and so on. Okay. In group 8A, as most of you know, the energy level is filled. These are the noble gases. Because of that filled energy level, they are unreactive. Now what I'm going to do is go and name some of these groups. Group 1A, this group, is called the alkali metals. And you've often heard the term alkaline. A lot of students want to call these the alkaline metals, but they are just the alkali metals. And the term alkaline really comes from compounds that might contain sodium and potassium. But the alkali metals contain these elements, sodium and potassium in particular, are pretty abundant in the Earth's crust. Groups 2A, or group 2A I should say, these are the alkaline earth metals. They have 2 electrons in their outermost energy level. They also contain some elements that are highly abundant in the Earth's crust, such as magnesium and calcium. If we go to the center of the periodic table, these elements have groups that end in B. This is groups 3B through 8B and groups 1B and 2B here. And we will discuss their electron configurations later on. But these are called the transition metals. And what's interesting about the transition metals is that many of them provide color to compounds. For instance, copper, when it's contained in compounds, give the compound a really pretty blue or greenish color, whereas cobalt will give compounds a very vibrant blue color, and iron will often give compounds a reddish color or a reddish brown color. So transition metals provide color to compounds in the natural world. They used to be used in paint pigments to provide these very vibrant colors. We can also divide the periodic table between metals and nonmetals. And if we could draw a staircase line that looks like this. I would be separating the metals from the nonmetals on my periodic table. Now, the metals are over on the left-hand side, the nonmetals are on the right-hand side. The elements here that are colored in green, here they're labeled as semimetals. You will learn them as metalloids. That means they have properties of both a metal and a nonmetal, and you will read more about what the properties of metals are versus what the properties of nonmetals are. So most of the elements, as you can see, are metals, and a smaller percentage of them are nonmetals, and then an even smaller percentage of those elements are called metalloids. The elements in these two rows down on the bottom, these are called the intertransition metals. And before scientists knew a lot about them, they used to be called the rare earth metals. And in fact, when I was in high school, that's what we called them. But they are now the intertransition metals. These two horizontal rows actually fit right into these two blocks right here. So if you could imagine like these two rows being two stacks of cards that have now been all laid out horizontally across the table so that you could see the face of each card as the symbol of each element. This is where they would go. And if you would restack them up into two piles, okay, the pile for this green row, the first row, the intertransition metals would go right here. And they would be atomic numbers 57 through 71. And the second row, horizontal row of the intertransition metals, if we piled them up in one stack, would go right here, atomic numbers 89 through 103, excuse me. So the intertransition metals actually fit into these two spaces here on the periodic table. So what should you know without referring to a diagram like this? If I gave you a blank periodic table, you should be able to label where the alkali metals are, the alkaline earth metals, the noble gases. Oh, we forgot a group here. The halogens. The halogens have 7 electrons in their outermost energy level, hence they're in group 7A. And also the representative elements and the transition metals. Okay, you should know where all of those are. You should know where the metals are versus the nonmetals and the metalloids. And also understand that these intertransition metals fit into these two boxes. They have similar properties to each other, so we're actually placing them in these two small spots of the periodic table. You should also be able to tell me how many electrons are in the outermost energy level of any element that is a representative element at this point.